Processes, threads, and concurrency. We have been talking about application server handling requests, but here is a question most beginners never ask. How does a single server handle thousands of requests at the same time? The answer involves two fundamental concepts, that is processes and threads. So what is processes? A process is an independent instance of a running program. It has its own memory space, its own resources, its own everything. When you run your application, the operating system creates a process for it. Think of a process as a separate kitchen in our restaurant. Each kitchen is completely independent. It has its own stores, its own ingredient, its own staff. They don't share anything. You can run multiple processes of your application. This is what happens when you deploy a multiple cores on the server. Each process handles requests independently. If one process crashes, the other keeps running. Now what is thread? A thread is a lightweight unit of execution within a process. So this is very important. Thread is a lightweight unit of execution within a process. So it is a part of the process. So one process can have many threads. So multiple threads share the same memory space of their parent process. They can communicate easily, but they also compete for the same resources. So if I want to give you analogy, processes versus thread, then consider kitchen versus chef. A process is a separate kitchen, own memory, own resources. A thread is a chef inside that kitchen, that is a shared resource. You can have 10 chefs in one kitchen, all working on different orders simultaneously. They share the fridge, share the counter space, sometimes bump into each other. That bumping, that's what we call as a race condition. Now you would have got the idea about race condition, right? So race condition means two threads are fighting for the same resource. That can happen. Now let's try to understand how server handle thousands of requests. Modern server use different strategies to handle concurrent requests. Multi-threaded model. For each incoming request, the server assigns a thread. If you have 100 threads, you can handle 100 requests simultaneously. Java and C# server typically work this way. The downside of this approach is thread consume memory. If you get 10,000 simultaneous requests, you need 10,000 threads. That's a lot of overhead. Second model is event driven model. Instead of one thread per request, you have a single thread or a few that manages all requests using an event loop. When a request needs to wait for something, a database query or a file read, it doesn't block the thread. It registers a callback and moves on to the next request. Node.js works exactly this way. It is incredibly efficient for the I/O heavy applications. Then another model in this is hybrid model. Languages like Go uses Go routines. Lightweight thread manages by the runtime, not the OS. You can spin up millions of Go routines with a minimal overhead. It combines the simplicity of one thread per request with the efficiency of event-driven architecture. So basically hybrid is a combination of these two. So one quick comparison will look like this. In multi-threaded model, one thread per request. Example of this is Java, C#, IIS. It's a CPU heavy work and balance the load. Event-driven single thread plus event loop. Node.js, Nginx work this way. It's a I/O heavy, many connections. Then hybrid Go routines, lightweight green threads. It is used by Go, Erlang, Elixir. It is best for high concurrency and mixed workload. Now one interview tip here is, when you choose a technology in an interview, connect it to the concurrency model. You can say, I would use Node.js for the notification service because it's a I/O heavy. Lot of API call. Not much computation. For the video processing service, I would use Go or Java because it's a CPU intensive. This shows you understand why behind the technology choices. So the key takeaway from this session is processes are independent execution environment with a separate memory. Threads are lightweight execution unit that shares memory within a process. Threads are the part of a process. How a server handle concurrency? It's in multi-threaded, event-driven or a hybrid way. Directly impact its performance characteristics and determines what workload it's best suited for.